Everybody, this is Scott Armas. Today I want to do some trials with zinc and lead, and this time zinc will be filling the sphere completely, and the mass is measured to be this, and the lead filled sphere, well, it's the same container, the same sphere, but the lead filling will be ever so slightly heavier because it's predicted to fall slower. So we don't want anybody to blame the difference in mass for that. And I put a little bit of paper in there to prevent the small lead balls from jumping up. Okay, so let's get started. This time there's no no sticker between the washer because it's much heavier this time. Okay, so this is lead. Let's clear this first. Five nine 5980. Okay. Five nine 80, exactly the same again. Lead has more binding energy than zinc. No, wait a minute, other way around. Zinc has more binding energy than lead, and that's why zinc has more gravity. 5979. Five nine 81. Five nine 81. 5979. 5980. 5978. 2 more tries. Then we have to switch to zinc. 5979, was it? Yes. 5979. The standard deviations are very small here. Okay. So now take this out. Put this here in zinc. Zinc is, the periodic table is close to iron, somewhat close, and that's why it has a gravitational constant similar to iron. Now it's not so easy to get all these back in. I had them inside before, but yeah. When the sphere is completely full, there's no way for anything inside to jump up. And that's good because if it jumps up, then it doesn't push down anymore. We shouldn't forget to also weigh it once more to be sure that the mass is correct, is equal to the other one. Equal and very tiny, a very tiny bit smaller. No, this is paper. It's also paper. Okay, so close it up. Now it's hard to close because the positions cannot be exactly the same as last time. Okay, now it's closed. So let's see how much it weighs. Okay, very good. Last time it was 9, here it's 11, and the lead one was what was it? 14 and then 16. When I started filming was 16. Okay. So that's well, yeah, that's fine. So zinc is supposed to fall faster, but it's slightly lighter. So that's good. Okay, let's get started. Five, 9, 7, 9. 5, 9, 7, 9. Five, 9, 7, 9 again. So far, so good. 5980. Make sure that it's centered well. A little bit more to the left. Okay. Five, 979. Five, 977. 5980. 5979. The standard deviations are very similar. But there's another question, that is if in this experiment the mean is really the best indicator. Maybe the median is better here. Five, 980. Or the mode, that's another option. When I was doing freefall experiments with that clamp release mechanism, there only delays were possible in the freefall time. Could only be too long, could never be too short, because well, could only the release could only be delayed, it could not be too fast. So here we use laser guides, so that's not really an issue. But yeah, when you consider the push of the magnet, I mean, that could 5977. Yeah, so as predicted, the zinc is faster, but the difference should be bigger. It should be yeah, it should be like 2.9, not 0.6. Yeah, but of course it's not. And here we see they almost don't overlap, but they still do overlap. And we don't know if these samples are still for that, if they're still jumping upward. And we have some outliners here. Yeah. Okay, but we see that it's very consistent, that that the elements that are predicted to be faster are really faster. And yeah, we don't know how important mass distribution is. It shouldn't really matter. Let's also look at the mode. Let's check the mode real quick. Mode. It's hard to type when I'm holding the phone for filming at the same time. Okay. So this is the mode. Okay. And normally the average should be the most accurate. Okay, so in the mode it's the same. What about the median? Median. And here. Yeah, very similar. The mean and the median are very similar. Here the difference is ever so slightly bigger. Okay, that's all for today. See you.